The video for tonight is on section 1.3. It's about real numbers and the number line. A lot of this stuff should be review, like a lot of the first chapter, but we need to go over a lot of this because we will be using it extensively this year. Starting with square roots, a is the square root of b if a squared equals b. Then we have an example here that 3 is the square root of 9 because 3 squared equals 9. The symbol in red here, a lot of people think it's a square root symbol. It's actually just a radical symbol, and it means the positive square root of, and the number under the square root would be called the radicand. So if we look down here, we can try out number 1. So that means what is the positive square root of 25? So if you want to think about that, you can pause the video and unpause it to check the answer. And most of you probably got this right. The positive square root of 25 is 5. If I had asked for it, the negative square root of 25 is negative 5, but I didn't. Number 2, the square root of 4 over 81. This might be a little more difficult. We'll see. That is 2 over 9. So essentially you can take the square root of the top and the square root of the bottom, because 2 over 9 times 2 over 9 would equal 4 over 81. And the third one, square root of 64, is nothing. No, I haven't done that one yet. Alright, so the square root of 64 is 8. Alright, so moving on. The square of an integer is a perfect square. So we have perfect squares. For instance, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. So perfect squares are 1, 4, 9, 16, 25, 36, and they go on forever. But the most common ones would be up through maybe 12 times 12. You see quite a bit. Since the number 45 is not a perfect square, we don't know the exact square root. It's between 6 and 7, because 6 squared would be 36 and 7 squared would be 49. So we know that the square root of 45 is between 6 and 7. We could use a calculator to figure it out. If we're not using a calculator, you can just say between 6 and 7. But even if you do use a calculator, you're only going to get an approximate answer, because the square root of a non-square number will be a non-terminating, non-repeating decimal called an irrational number. So we're going to talk some more about irrational numbers and kind of all real numbers in general. And I have a little slide here, and basically the real numbers are, and we can start with these natural numbers here. So natural numbers are 1, 2, 3, and so on. A lot of people call them the counting numbers, and they go on forever, so up to 1 million, 2 million, and they keep going. The whole numbers, you'll notice that the natural numbers are inside the whole numbers box. So here's the whole number box, right? And you'll see that the natural numbers are located inside of the whole numbers, because the whole numbers include the natural numbers, but they also get 0. Okay, and so when you look at the integers, notice the integers, the integers get all the natural numbers and that 0, which would say all the whole numbers, but they also get negative things, so like -1, -2, -3, and forever and ever and ever to the left on the number line. Then the rational numbers are all those ones that we've talked about, so the naturals, the whole, the integers, but you also get things like fractions, like 2/3, or -4/5, or a repeating decimal of 7. Now over here we have the irrational numbers, like we just mentioned in the previous slide. The irrational numbers do not include any of those other things we've talked about. So not natural numbers, not whole numbers, but it's its own special set. And here you get the square roots of non-square numbers, so like square root of 2 or square root of 7. You get negative square roots as well, as long as they're not perfect squares, so like negative root of 26. You get things like pi, which is also a non-terminating, non-repeating decimal. And you'll notice we have real numbers up here, and real numbers include everything we just talked about. So real numbers would include irrationals, rationals, integers, whole numbers, and natural numbers. The one thing that's not written down here, and you're not going to really need to know about this until probably pre-calculus, is there's something called imaginary numbers. And you can look that up if you want, but we don't need to deal with those this year. So what I want you to do now is try to classify each number. So what I mean by that is what sets of numbers do these fit into? So I'm going to give you a little split screen here. So the number 12, what sets does it fit into? Is it a natural number? Is it a whole number? Is it an integer? Can it be more than one of these? Is it irrational? So let's look here. It's a counting number, so it's natural. And because it's natural, it also has to be a whole number, and it also has to be an integer, and also a rational number, and a real number. So 12 is everything except, so we'll say everything except irrational. We'll just use short words here. So everything except irrational numbers. Now we have number 2, we have a negative decimal. So it's not natural, it's not whole. It is negative, but it's not an integer. And so it is rational, because rational is includes negative numbers that are not integers. So it is rational, and since it's rational, it is also real. So number 2 is rational and real. Number 3 is the square root of 21. So we have to first decide if that's a square number. So no, it's not a square number, so that means it is irrational. And if it's irrational, it's also real. So real and irrational. Okay, so what I want you to do now, let's go full screen here. Put these numbers in order from least to greatest. So pause it and try it yourself, and then we'll see what you come up with. Okay, I made a number line here, even though it doesn't necessarily say to graph it, but I think it'll be helpful to graph it. So square root of 9 is going to be 3, so I'm going to put that right here, square root of 9. 0.3 is in between 0 and 1. It's right around here. So I'm going to put 0.3. And we have negative 1/4. That's going to be between negative 1 and negative, no, between 0 and negative 1, sorry. So negative 1/4 is kind of around there. And then we have square root of 3. Now I don't know exactly what that is, because it's not a square number. But since the square root of 4 would be 2, and the square root of 1 would be 1, it has to be somewhere in between 1 and 2, and it's probably closer to 2. So I want to put that about right there. And then negative 4.25 is all the way over here, probably about right there. Negative 4.25. So although I don't know exactly where square root of 3 goes, just by putting it somewhere on a number line, I can see, at least with respect to these other numbers, where it goes. Now, if I really wanted to figure it out, I would use a calculator and find an estimation of that. Now, we can put these in order from least to greatest using an inequality symbol, or several inequality symbols. We go negative 4.25 is less than negative 1/4, which is less than 0.3, which is less than the square root of 3, which is less than the square root of 9. Alright, and that should do it. Don't forget to fill out the form below.